Just deleting all of my old stuff. Hopefully you're doing this along with me. Remember, you plug in x instead of t because your calculator only has it as a function of x, so we know we're just treating it like x. We graph it, and I have a weird zoom left over from the last thing I was doing on this calculator. So first, I'm going to standardize my zoom, which actually ended up working out pretty nicely in this case. I'm going to click and drag it over, but then I notice that my window is not quite what it's supposed to be for the domain that it gives me. So I'm going to go in and change my window settings and just make sure that my maximum goes up to like 25 or something like that. So I can kind of get an idea of what I need to do. If we're talking about depth of water in a harbor as a function of time, time won't be negative, right? So our y-axis can be fully over to the side because we won't have any negative x values. So I will draw in my y-axis to the side. And also we can see from here that we aren't going into negative y values. They haven't decided to make depth negative in some sort of way, which they could if they were talking about like a positive value being above the surface of the water and a negative value being below the surface of the water. So it could in some of these modeling functions, but this one it doesn't. So this is time in hours, and this is depth, which we've used h for depth in terms of meters. And I want to go from 0 to 24. And if you count this all out, we'd have like 25 tick marks down here. So we're going to go by ones in the denominator. But because I am lazy, I'm only going to label every other one. Efficient? Maybe I'm just efficient. Looking at my y values, I know, actually, we can go from our up here piece of information. I know that 4.7 is going to be my maximum value, and 2.4 below that is going to be 2.3. So 2.3 is my minimum value down here. So I know I really only need to go up to 5. And I think there's like 20 tick marks here. So I did 20 divided by 5, and I realized I could go every other 4 boxes. So that way I'm using the whole space and I'm not cramped. And it looks nice. Okay, and then you need to grab out a few pieces of information, mostly your maximums and your minimums, all minima and maxima, all of the ones that happen within this domain. You need to make sure to graph all of those. Make sure you also include the y-axis, y-intercept. It happens to be a y-intercept that is a maximum, right? Because we start at the first high tide. But those are the things that you need to grab when you graph. So you can just grab it from your calculator, all of your maximums. And all of your minimums. And start graphing. So technically I've graphed just a little bit outside of that 24 domain. I wanted that just so I could finish the maximum and kind of get the general idea of the curve. You could erase it so it is exactly at 24, but you could also just have that point that's just slightly outside of 24 to try and complete the idea of the curve. That's fine, as long as you make sure that you do include up to 24. So these are all the things that you need to do. You don't need to label unless it asks you to label. It's good to have clear, precise points, because if you get follow through points for having something wrong up above, if I see that you've used that wrong point correctly on the graph, then you can get follow through points. But if I don't see where you've brought that point in, then I can't give you follow through points. So making sure that the points that you do sketch are clear. If you want to label them, that's the way to make them the most clear, but it also takes time. And we know that we're always running out of time on tests anyway. So this is the thing that we're looking for. You need to have a scale on your X and Y axis. It needs to be labeled. You need to have all intercepts graphed with a clear point, and then other key points. So maximums, minimums, etc. And make sure that you include the domain if it tells you a domain that it needs to be in. Okay, last question for the notes today is an IB question. You can see it's a long IB question, right? So these would be like one of your paper 2 questions where it's a lot of marks. So a person on Vienna's famous Riesenrad Ferris wheel can be modeled by the function h of t equals, and notice that we have some pieces given to us, but not all pieces, right? Everything inside of the cosine function is given to us, and everything outside we need to find, which we know is amplitude and principal axis. So we're talking about kind of like top and bottom of what's going on with a Ferris wheel. So circular motions are represented by trigonometric functions because there is still this idea of a cyclical pattern, right? You go around in a circle and you complete one whole cycle of a circle, and you have a minimum height and a maximum height, just kind of like your waves. Just your function will always be a function of time, not of horizontal distance, right? Because if you did horizontal distance versus vertical distance, it would just look exactly like it is a circle, right? But if you do as a function of time, you can say, well, at 0 minutes, I'm here, and at 5 minutes, I'm here, 10 minutes, I'm here, 15 minutes, I'm here, and 20 minutes, I'm here. As a course of time, 5, 10, 15, 20, 0, I'm at my minimum, 5, I'm halfway up, 10, I'm at my maximum, 15, I'm halfway down, and 20, I'm at my minimum, right? So there is this idea of a cyclical pattern. And if I do it multiple times, then it's just going to keep repeating. And so since it's a function of time versus height, it becomes that trigonometric function. So you'll see this a lot, this like circular motion idea. It happens a lot in the applications of trigonometric problems. Okay, so the thing that we care about here is amplitude and principal axis. So things dealing with the height. So it says, given that the diameter of this Ferris wheel is 200 feet, deduce a value of A. Well, if our Ferris wheel is a circle and we have a diameter of 120, when we talk about our minimum height versus our maximum height, right, our A would be the distance halfway between your maximum and your minimum height. Your minimum height would be at 0, right? 0 would be your minimum height. And then your maximum height would be, well, the diameter, right? This is the same as 120 because it's a circle, so the diameter stays the same. Which means if your total distance is 120 between the top and the bottom, then A would just be half of that. So with circular motions, A, your amplitude, is always your radius. Your radius is always from the center of the circle. It's the distance between how tall you are and how down you go from the center, right? So A is just equal to 120 divided by 2. So A is equal to 60. Now, we have to think about this in regards to one other thing. We might have mentioned it before, but maybe not. A also determines whether we start at a maximum or whether we start at a minimum. And it's whether or not it's positive or negative. Sorry, not 120. I bet you all think I'm crazy. Sorry. The diameter is 200. So 200, 200, 200 divided by 2 is 100. So